So we'll go ahead and get started. Welcome, everyone. Thanks so much for being here today. We're really pleased to have you here with us. My name is Mary Blanchard. I'm the Associate Director of the Wisconsin Energy Institute at the University of Wisconsin-Madison. Today's event is part of a broader initiative to strengthen the bioeconomy ecosystem in Wisconsin and the Midwest. Our goals are to build shared understanding and to facilitate connections among stakeholders. The topic for today is carbon management, which we see as offering tremendous opportunity for ag, forestry, and industrial sectors in this region. As you likely know, a carbon management ecosystem of markets, government policies and incentives, and new technologies and industrial practices has been emerging. It offers potentially profitable opportunities to reduce carbon emissions and/or sequester carbon, which will better ensure the long-term sustainability of these practices. Today's event is specifically focused on carbon management solutions in the bioeconomy, so those related to biomass or to biotechnology. I wanted to tell you a little bit about the Wisconsin Energy Institute and this initiative overall. The Energy Institute is tackling one of the most challenging issues of our time, the transition from fossil fuel dependence to new clean energy systems and solutions. We're specifically focused on generating knowledge and innovations for sustainable power, fuels, and chemicals. We do this in three ways: fostering collaborative energy research, bringing together researchers from across disciplines and sectors to solve challenges, cultivating public understanding, and ignite future leadership through education and outreach initiatives, and developing stakeholder networks and sharing expertise to solve challenges and create economic opportunities. Today's event is an example of this third strategy. In all of this, we want university research and outreach to help solve problems and make a positive impact for the state of Wisconsin and its citizens. Today's initiative is funded by the Innovation Incubator, which is a collaboration between Wells Fargo Bank and the National Renewable Energy Lab. It is focused on energy and agricultural sectors. And it has an accelerator program and offers support for innovation ecosystems nationwide. I'd like to thank our workshop promotional partners, Energy on Wisconsin, the Wisconsin Sustainable Business Council, the Wisconsin Tech Council, and the Wisconsin Biogas Council for their help with this event. I wanted to give you a vision of our vision of the bioeconomy, in which purpose-grown non-food biomass, organic and gaseous waste is converted into fuels and power, materials and chemicals. Many kinds of products, including pharmaceuticals, biopolymers, surfactants, and more, can be made from plant biomass. Together, these enable agile, resilient, and sustainable industries and supply chains, especially benefiting rural communities. The new bio-based products can benefit a wide, I'm sorry, I'm being a little bit distracted. Sorry about that. Can benefit a wide range of industries, from the chemical industry to plastics products manufacturing to dairy processors, which could potentially convert current waste streams into valuable products. Technology innovations in this space could boost the value of Wisconsin's forestry and non-food ag products and provide new revenue streams to farmers and manufacturers. The bioeconomy could augment rural economic development and be a catalyst for brand new industries across the state. The Circular Bioeconomy Initiative has started with 3 workshops. The first happened in November on renewable natural gas, today's workshop on carbon management, and on February 2nd, we'll have a workshop on sustainable aviation fuels and chemicals that'll be in Madison. We focused on 3 areas that can be deployed right now and offer significant opportunity for this region. Again, the goal is to create shared understanding and strengthen stakeholder networks. We'll specifically be seeking to document opportunities and barriers to fully developing a circular bioeconomy to help inform the path forward. There will be 2 conferences to be held in the spring. Dates will are still to be determined. And we're going to be assessing the interest in an ongoing organization and or regular meetings of this community. I wanted to just quickly introduce the folks who've been part of the planning for this event and are here with us today and will help moderate some of the breakout sessions. Allison Bender, who's WEI's Outreach and Events Coordinator. Scott Williams, who's WEI Research and Education Coordinator. Deb Gurke from the UW-Madison Office of Strategic Consulting, and also Steve Bialak from the Office of Strategic Consulting. Deb is going to be the moderator for today's event, so I'm going to turn it over to her now.
Thanks, Mary. So the first thing we're going to do is just to put us in the space of what we're going to be doing today and just quickly review the agenda. So we're going to start out talking about carbon management activities in Wisconsin agriculture, then carbon management activities in Wisconsin forestry. Then we'll take a little break. Then we'll come back and talk about carbon management on the farm and how to develop a business case. Then we're going to have a focused conversation where we're going to ask you what you think about these presentations and get your feedback, because that's really important. That's one of the most important aspects of this meeting today, is to find out what the people out in the world actually doing this work need and what kind of support and understandings we can bring to them. Then we'll break for lunch, and then we'll have some 4 case studies this afternoon, followed by another focused conversation to wrap up the day and to discuss where we might go from here. And Mary will finish with some final remarks. We will also have a breakout room open over the lunch hour, and again, some breakout rooms open at the end for people who might want to do some networking. So we'll talk a little bit more about those opportunities at the time, but we know that in-person events often provide that networking opportunity, and we want to try to replicate that a little bit here. And just to get a little sense of who's in the room, in the chat, if you would, just take a second to, pop in your name and where your location and what brings you here today. What's your interest in carbon management? And then we're going to follow that up with a little Zoom poll. We just want to know, what sector you're a part of. And just if you take a moment to submit that would be awesome. And then we'll move into our actual speakers after that. I don't know. I'm not seeing any names in the meeting chat or people. Oh, there we go. I thought maybe the chat is down on the bottom just to help you if the problem is trying to locate it. It's kind of almost in the middle, the 4th icon from the left. And we'll pop up that poll after people have voted, and just to get a sense of who we have in this virtual room. There we go. Now people are getting the hang of it. Awesome. And it takes a minute sometimes. And Scott, whenever you're done getting votes in on that poll, if you want to pop that up for us to see, I believe you can screen share the results of that.
Sure. We don't have everyone voting yet, but I don't see any new additions, so I'll end the poll now and we can share the results.
All right, awesome. So it looks like we have a representation from each of the sectors that we've listed there. So that's really great. Mostly nonprofits and education, some government and industry folks, some forestry and ag folks, and then a chunk of others. Be interesting to know who those others are. People are still responding in the chat. Wow, we've got some cool people here, all kinds of interesting things represented. All right, kind of looks like maybe we're pretty close to being done with that. Oh, nope, got a couple more yet. All right. So again, to echo what Mary said, welcome everyone. We're going to jump in and get started with our first speaker, who is going to provide a carbon management overview. Greg Nemet is a professor at the University of Wisconsin-Madison's La Follette School of Public Affairs. His research and teaching focuses on understanding the process of technological change and the ways in which public policy can affect it. He teaches courses in energy systems analysis, policy analysis, and international environmental policy. Professor Nemet's research analyzes the process of technological change in energy and its interactions with public policy. Greg, I'm going to turn it over to you so you can share your screen and get going.
Thank you, Deb. Thanks for that kind introduction. And thanks to all of you for your interest in carbon management. So what I'd like to speak with you about today is kind of a big picture, global perspective. And so it's probably a nice way to start the meeting before we get into like the actual implementation on the ground, which is really what will make this matter and significant. So I'm a lead author on this report, which we're calling the State of Carbon Dioxide Removal. And I'm doing this presentation on behalf of a large author team of about 20 people from around the world. And there's 4 lead authors, one of which is me, and I'm encouraging you to join our launch event, which is tomorrow I think it's at 10 o'clock Central Time. And we'll have each of the authors will talk a little bit about some of this material I'm talking about today. We'll have a guest speaker who heads the Office of Carbon Management at the U.S. Department of Energy, Jen Wilcox, and the moderator for the event will be the environment editor for The Economist, Catherine Brehech. So yeah, let me talk a little bit about the report. Our main takeaway, so if we had to say one thing from this work we've done over the last 2 or 3 years, is that scaling up carbon dioxide removal is an urgent priority, as are efforts to rapidly reduce emissions if we are to meet the temperature goal of the Paris Agreement, which is to keep global warming below 2 degrees and make efforts to limit it to 1.5 degrees. And we're already at 1.2, so there's urgency. So drawing together analysis across several key areas, this report is the first comprehensive global assessment of the current state of carbon dioxide removal. And the scope of this report is global. It also includes all forms of carbon dioxide removal, and we'll define that in more detail in a minute. But in short, carbon dioxide removal involves capturing carbon dioxide from the atmosphere, storing it durably on land, in the ocean, in geological formations, or in products. And there's many different types of ways to remove carbon from the atmosphere, and I'll talk about those in just a minute. One of the distinctions that we'll make is between what we call conventional carbon dioxide removal, and that's where we capture and store carbon in the land reservoir. So some of the things we'll probably talk about today is storing carbon in crops, in soils, and in trees fit under this idea of conventional carbon dioxide removal. And that's mostly what carbon dioxide removal is happening today, like 99.9% of it. We also have this other type of carbon dioxide removal that we're calling novel CDR, and that's everything else. And that includes things like biochar, bioenergy with carbon capture, and using chemical processes like direct air capture. And just to give you a sense of the motivation here, I think we're kind of seeing carbon removal and carbon management is similar to where renewables were about 25 years ago. And it was a nascent industry. It wasn't really taken seriously. It was very small. And most important, there was really scarce data about how many projects were happening, where they were happening, the returns on those projects, the cost of the projects. And about 20 years ago, there was an organization called REN21. So it was like Renewables for the 21st Century that started, and they just started collecting data on how many projects had happened in different countries and which types of projects. And that really provided kind of shared knowledge base for how the industry was developing and where growth was happening. And you could start to do things like assess what policies were effective, because you could start to see where a lot of projects were being implemented. And that REN21 project eventually led to a international organization called the International Renewable Energy Agency that's now a large organization and does a lot of these same functions in terms of collecting data and making it available to the industry. And so renewables has become a global industry and a key contributor to addressing energy issues and climate issues. And we are thinking that carbon dioxide removal could play a similar role, but what's missing is a comprehensive assessment of what we know about it. And so that's our motivation for compiling this state of carbon dioxide removal report. And we're thinking this is probably the first in a series of reports. And so we're meeting in about a month to make our plans for the next report. Okay, so that's on the report. Oh yeah, the other thing I should mention, we have this red text that I was told to put everywhere. So the report is embargoed until, I had to make the translation, it's Thursday morning UK time, but it's 6 p.m. today. And so I ask you not to share any of this information until 6 p.m. when we launch all our media and report and information about it. And Mary had asked for the slides, and I said I would provide the slides after this embargo date, which is by this evening, so I can share the slides tomorrow. Okay, so let's check here. There we go. Okay, so key messages. So for the first time, this report compiles an estimate of the total amount of carbon dioxide removal currently being deployed around the world. And the answer, how much, is 2. So 2 billion tons, 2 gigatons of carbon dioxide are being removed per year worldwide. And almost all of that is from conventional carbon dioxide removal on land, mostly through forestry projects. The second type of carbon removal, which is this novel carbon dioxide removal, this is everything else. It's about 1/1000th of the scale, so 0.002 or 2 megatons of CO2 per year from novel CDR. And I'll talk about the different types of that in a minute. So that's the first takeaway. The second key message is that there's a gap between what countries have proposed in terms of how much carbon removal they plan to do in 2030 and by 2050 as well. There's a gap between that and what scenario analysis says we need to do to put us on track for the Paris Agreement goals, which is 2 degrees and 1.5 degree temperature change. And again, we're already at 1.2. The third point, and this is always one of the main points when we talk about carbon removal, is that carbon removal is a pretty small part of the overall solution to climate change in some ways. It needs to be way bigger than it is today, and it's essential to do it. But we're only talking about maybe 1/6 of the mitigation for climate change is going to come from carbon dioxide removal. All the rest is from reducing emissions. And the more we do that, the less we need to do carbon dioxide removal. And some of the indicators of carbon dioxide removal moving are in research. That's in terms of publications. So we now have 28,000 publications, and we've reviewed them for this report, mostly in technical and engineering issues, but much fewer in social science journals. And we actually think there's a lot more need for understanding things like public acceptance and markets and how people interact with the system. We have about $4 billion worldwide in public R&D, research, development, and demonstration, but almost all of that is in the proposed direct air capture hubs by the US Department of Energy. We're seeing a lot of patenting. The biggest source of patenting, or the country with the most patents, is China, and we're seeing a more diverse set of patents being applied for. And we've also done a social sentiment analysis. So we looked at sentiments of people posting on Twitter on carbon dioxide removal. And generally, the sentiments, the words that people use are positive. The one technology that doesn't have that same impression is bioenergy with carbon capture and sequestration, which tends to have negative sentiment when we analyze the tweets from those technologies. So those are the main messages. Let me go deeper into a couple of areas. And one is just to survey the landscape here. So here's our definition of carbon dioxide removal. It's methods that capture CO2 from the atmosphere, durably store it, and they must be additional to natural processes. So we've got a couple of examples of taking CO2 from the atmosphere, and that's principle one, durably storing it, for example, in trees. and then you could have biological storage as well. So these are just a few of the different pathways for CO2 getting used. We wouldn't call this middle part carbon dioxide removal, because then CO2 is being captured like with a machine with direct air capture. It's used in a fuel, but then goes back into the atmosphere. So that's not, that's maybe offsetting some fuel use and maybe providing an important feedstock, but it's not doing carbon removal. Okay, and then carbon capture and storage is the picture on the right, and that's also something we're not including in this report. So just some boundary conditions about what we include and what we don't. Lots of different CDR methods though, and just want to outline them at a very high level just to start. So first of all, we can think of photosynthesis and storing CO2 in trees. That's the forestry one. We can think about taking CO2 into wood products and storing it as timber, as for building material, for example. We can think about storing CO2 in soils, potentially really large potential for storing CO2 in soil, carbon in soil. And then we can think about crops that would be using that CO2 as well. And then on the right side, we can start to think about things like biochar, where we'd use photosynthesis, then do some form of pyrolysis and turn that woody material into a char, and then the char can stay stably in soils for long periods of time. Then we can think of bioenergy with carbon capture and sequestration, where the CO2 gets combusted, but then not vented into the atmosphere, but captured and stored underground. That's sometimes called BECCS, and the largest BECCS plant in the world is in Decatur, Illinois. We can think about doing things like iron fertilization, where we can grow algae that sinks to the bottom of the ocean, and there's ocean CO2 capture, and then others like enhanced weathering. And then on the bottom right, we have another form called direct air capture. So lots of different channels to take CO2 from the atmosphere and store it underground. And what we try to do in this report is survey all of them. And I think if we're talking about the bioeconomy, we're generally talking about the left-hand side of this diagram here, and probably not talking about direct air capture, not talking about enhanced weathering, and probably not on the ocean forms, but all the other ones I would call some form of bio-based carbon dioxide removal. Okay, so, and like I said before, we made this division between conventional CDR on land and novel CDR. Okay, so then the next point that I made in the key points, I just want to illustrate with a few pictures here, is the CDR gap, the carbon removal gap. And it's a gap between what countries have planned to do and what we need to do. So here's the data that we put together. This is the first global picture of how much carbon removal is happening. And so we're at around 2 gigatons. So that's the graphs here are generally negative because we're talking about removal, not positive emissions. So it's going from right to left. So maybe a little counterintuitive, but that's how our graphics people did it here. 2 gigatons of CO2. Almost all of it is from conventional CDR on land, mostly growing more forest, afforestation, and a small part, so 1/1000th of the total carbon removal is on these novel methods. The novel methods are the ones that are getting the patents, getting a lot of the publications, getting a lot of the funding, but it's all about future growth, because right now those are tiny. So we've got this bioenergy that's about 1.5 million tons of removal a year, and I think about 40% of that is coming from that ADM plant in Decatur, Illinois. So that's the BECCS part. Then we've got biochar at small scale in lots of different places. And then we've got a tiny amount of nascent other things like direct air capture, including some small plants around the world. So that's where we are today. If we look at scenarios, this is a lot of the people I work with, we work on pathways to address the climate problem by reducing emissions. And you can see this is a time scale of 100 years here for the whole course of the 21st century. And we're at something like 40 gigatons of CO2 per year that we're putting into the atmosphere. So 40 billion tons going into the atmosphere. And these scenarios say that we need to reduce those emissions to get them to net zero by around mid-century. and then go below net zero after that. But we've also got negative emissions happening even before mid-century to compensate for things like sectors where it's really hard to completely reduce the emissions. So that's the challenge. And if we didn't focus on how much CDR is in these scenarios, it's a feature of all the scenarios that meet the Paris temperature goal. So we have to reduce emissions, but even with immediate and steep emissions reductions to get to net zero by mid-century, we depend on doing a lot of CDR. And we're starting from around 2 billion tons today and scaling up to something like 4 in this scenario where we do a lot of reduction in energy use and reduction in emissions that way, to something like 7 if we're focusing on a lot on renewables. We still need to do something like 7 gigatons in removal. And then if we use strategies where we're really focusing on maximizing how much carbon removal we can do, then we're up to something like 10 gigatons per year. So going from 2 to a range of between 4 to 10, and then, you know, that's at the median. And then we've got scenarios where we don't have to do much more than we're doing today. And then scenarios where we're doing like almost 10 times more than we're doing today. So lots of space, but then also lots of growth. And so what we then do is to say, where does that, what type of carbon removal is growing to go from like 2 gigatons today to 4 or 8 or 10 in the next 27 years? So here's just to walk through where some of that growth comes from. So if you look at that small bar on the left where it says current level, that's our 2 gigatons of CO2 per year of removal that's already happening. And then as part of the Paris Agreement on climate change, countries have to submit their plans for how they're going to reduce emissions. And you can go online, they're all transparent. And that's what we did. And we read them all and figured out how much carbon removal is included in each of those plans by every country. They have this 2030 plan that's called their Nationally Determined Contribution. That's the NDC. And they also have a long-term plan for 2050. And so we added up all their plans for carbon removal, and we get to a number of about 2.6 by 2030 and 2.9 by 2050. And you can already start to see that there's a gap here. We're at 2. Countries are saying we're going to get to almost 3 by mid-century, but the scenario is saying we need much more than that, like 4 or 8 or even 10 gigatons a year. So that's where we start to have a gap. So there's a gap in the proposed levels of carbon dioxide removal and what is needed to meet the temperature goal. So these orange bars here are starting to say, here's scenarios that would be consistent with this temperature goal. And the arrows there are the gap. So there's a gap between 2.6 in 2030. That's where, if you add up all the countries' plans, that's where we get, and about 5.5. So we're missing about 3 gigatons of carbon removal that we're going to have to find a way to do in that focus on renewables scenario. And the numbers are higher as we go out further to 2050. So the conventional CDR on land increases, and they're large. But in terms of the increase, we're talking about an increase of something like 30% between 2020 and 2030, and maybe an increase of about 100% by 2050. So the land use CDR, which is a lot of what we're talking about today, does have growth in it of something like 30% or maybe 100% by 2050. So there's a gap on the land use side that needs to increase, and I think that's what we're talking about today. On the novel CDR, we're starting from pretty close to 0. So we're at 1 or 2 million tons a year. So we're 2 billion tons is what's happening in the land use sector, but only 1 million tons from biochar and bioenergy with carbon capture and direct air capture. And so those have to scale up tremendously. So on the order of 30 times by 2030 and a little bit more than 1,000 times by 2050. And the long-term strategies do not have that in their plans. And so that's where we've got a really big gap between where we are today, where countries say we'll be in 2030 and 2050 with their plans, and where we need to be to meet the Paris Agreement targets. So to sum up this here, that a robust strategy then is for meeting the Paris temperature goal is to limit the dependence on CDR through rapid and deep emissions reductions while also aggressively developing and scaling up novel CDR. So it's a three-part challenge: reduce emissions, increase conventional CDR on land, and rapidly scale up this novel CDR. So we also looked into policies that around the world to deal with this. And so here's again this long-term 100-year plan for getting to net zero by mid-century and implementing removals. Those are the negative bars on the bottom. And you can see we've got 120 national net zero targets. So 120 countries, and I think it's now something like 80% of worldwide emissions are occurring in countries that have set a net zero target for between 2050 and 2070. But even though they've got this net zero target, if you're saying you've got a net zero target, that implies that you're doing some removals, and those kind of colored lines below zero on the bar show how much removals are implied. But when you look at the plan, there's only a few with actionable carbon removal plans. And so what we're saying is we need proactive policymaking, mainly in front runner countries like the US, the EU, and not so much at the UN kind of global level. I think that's where we kind of need to start here. We've done 4 case studies in our report on the EU, the UK, US, and Brazil. And there we see tangible progress and some policymaking dedicated to CDR. So far, it's a focus on conventional CDR. So that's the bio-based economy. But we are seeing more attention on novel CDR, things like direct air capture and bioenergy with carbon capture. And so we need to focus on carbon dioxide removal to reduce net emissions and reach net zero and not get to net negative. On innovations, this is starting to look at some leading indicators of where effort is happening in carbon dioxide removal. We've got a few different things that we look at. And one of the first things we do is just to think of innovation as this 2 different sides to the innovation process. There's supply side factors. So changes in technology, efforts at R&D, things on improving the availability of knowledge for CDR technology. And on the right side, it's about demand, creating markets. And what we know from historical work on innovation is that successful innovations couple a technological opportunity with a market opportunity. And that's why it's helpful to look at both sides. So the supply factors are ways to increase technological opportunity by funding science, by funding research, training engineers, and things like that. And the demand side factors create a market opportunity by finding niche markets where you might have high willingness to pay, creating demand by subsidies or markets, and then also dealing with public acceptance, which in general seems positive from some of the indicators we've looked at, but also has issues that need addressing as well. And so what we try to do is do metrics that would capture some of what's happening in each of these areas. So I'll just highlight a couple of them here. One is to look at patenting. So patenting is an indication of inventive activity. So this is a search of all worldwide patents on carbon dioxide removal. And you can see in the top panel that we've got a steady increase in patenting. The years there are year of application for a patent. And because it takes about 2 years for a patent to get granted, and we only count these applications if the patent's eventually granted, we have lower numbers in 2019 and 2020 just because those are applications that are still in the patent office. But you can see there's been this rise through 2018, which we'd expect to continue to present. That's the top panel. The second panel is looking at it by country, and you can see this big share by China that's been growing. The last couple of years might just be because China approves patent applications faster than other countries do. So that might be why we have overrepresentation of China, but that's certainly been the geography that's been growing fastest. And then if we look at patenting on the bottom there, we see the biggest source of patenting is on direct air capture. That's that kind of middle bar there. But over time, it's become more diverse. We have a broader set. So I think it's actually encouraging to me that we have a more diverse set of patents going forward. So that's just one indication of where some of the technology trends are going. The other thing we've looked at is looking at projections from industry groups and companies to see where they're going. And so we've got 3 technologies we focus on here, looking at direct air capture on the left panel, biochar on the middle panel, and bioenergy with carbon capture on the right panel here. And so these are log scales. So that means that each is a factor of 10. And we can see that the growth expectations are quite steep. We're going over orders of magnitude. And then the gray bars at the end just show where we expect to be by 2050. So you can see some of the patterns of growth there. But I guess the main takeaway I'd say from this one is that we're still talking about growing by 4 or 5 orders of magnitude. So a factor of 10,000 over the course of the next 27 years to get to 2050 here. So really rapid growth and faster than most historical technologies. That's something we've also looked at. One of the, this brings up is this idea of a formative phase. And that's this idea that the first 10 or 15 years of a technology's development area can really put into process a period of growth, or it can also lead to the kind of the stagnation of that technology so that it never really gets to be significant. And we find for carbon dioxide removal, especially novel types, the next decade is crucial, since the amount of CDR deployment required in the second half of the century will only be feasible if we see substantial new deployment in the next 10 years, which is novel CDR's formative phase. Okay, so I will stop there just to thank you to all the authors on the reports. I think we had about 20 or so authors' contributions from lots of different places. We're really planning to scale up the community of people working on this for our next version of the report. So it's going to be a much bigger set of people next time. It's been really helpful to have people's comments and reviews throughout the process. And we really thank people's work on that. And then the project team that helped us put together the graphics and collate everything has been really helpful as well, because it's really been a international team working virtually over a short period of time to produce this report. And then thanks to the lead institution, so it's Oxford University, the German Institute for International Security Affairs, MCC in Berlin, the La Follette School of Public Affairs at UW, and the International Institute for Applied Systems Analysis in Vienna. And thanks to our funders as well, listed on the bottom there. So if you are interested in hearing more and also hearing from the other authors, we'll do a version of this tomorrow online, and you can get the report when it's released at this URL, stateofcdr.org. So thanks for allowing me to participate today, and thanks for your interest in carbon management.
Thanks, Greg. We do have one sort of a request in the chat to expand on the negative social sentiment towards BECCS. Can you say something about that?
I don't know too much about that, but it was striking. And, it was one of those things where, I think some of the editors of the report were saying, it looks like we're picking on bioenergy with carbon capture, so maybe we should just not say that. But when we look at the data, it's just so striking that all the other technologies generally have neutral sentiment. And there's something about BECCS. I'm just trying to think if I have any more backups information on that. One sec here. Yeah, let me just show one slide to substantiate, to answer that question here. So this is how we did it. We looked at tweets, and I think we've got something like hundreds of thousands of tweets here. And we were able to do this machine learning to use a type of words and adjectives that people use in the tweets to say whether the sentiment was negative or positive. And you can see that if your bar is mostly on the right, then we're talking about a technology where the sentiment is mostly positive, and if it's going left, it's negative. And the other one that's negative, I should have mentioned, is ocean fertilization. So that's been actually deployed and had a lot of, this was about 15 years ago off the coast of British Columbia, and had a lot of negative reactions because it was done without much public engagement. And so that's probably where a lot of that negativity comes from. And then I think the trends is interesting too, to look over the last 15 years at the direction. I think that's where we picked up on this bioenergy with carbon capture being negative, because it's not only, it's, you know, kind of about half and half, a little bit more negative than the others, but the main thing is it's been trending negative. And I think just more kind of substantively what's been driving that is there has been quite a bit of coverage in the news about, does bioenergy with carbon capture just involve cutting down forests in order to create the feedstock to create bioenergy that we would then capture to remove CO2? And I think that's somehow been a very, I don't know, catalyzing idea. It has a lot of visual imagery and it's gotten a lot of news coverage. And so that seems to be something that's picking up some of that negativity that's escalated in the last few years. So yeah, thanks for that question.
And then just to confirm, the data source was limited to Twitter feeds, correct?
Yeah, right.
Perfect. We do have a couple minutes if we have another question.
Okay.
We can do maybe one or two, depending on how complex they are. If anyone has any. You can either pop it in the tweet, or if you're feeling bold, open your camera and your mute and engage a little more directly. It's up to you. Give that a second to see if anybody has anything.
Yeah, I have a comment up. We have a bad reputation for waste to energy, municipal solid waste to energy. And if we would redesign our packaging system where most of our domestic waste could be burned cleanly, that would be a source of carbon dioxide, which could be used as a feedstock wherever we wanted it. And but it's a long haul to convince people that burning trash is a clean activity.
Mm-hmm. Yeah. Yeah.
So
I'd
like to see some work on that.
Right.
Great, thanks, Lee. Then in the chat, we have a request for a little more explanation on BECCS.
Okay. Just trying to think what direction you're most interested on that with BECCS, be it bioenergy with carbon capture and storage. But I can just riff for a minute if there's so the basic idea is you do photosynthesis, so put CO2 from the air into carbon in crops, dry the crops, burn them, combust them, you get energy and heat, you can make electricity with that, that's valuable. And then in the combustion process, you're creating CO2, and then you can do capture of the CO2 in this power plant and then compress that CO2 and put it underground. So it is negative, it's going carbon in the air into crops and then underground. And then you have this byproduct, which is electricity. So when we look at some of these models, they tend to like it because it's reducing CO2 and it's providing a valuable good of electricity. So far, there's only one large-scale BECCS plant in the world, and that is Archer-Daniels-Midland ethanol plant in Decatur, Illinois. And it's a little bit of an easier rig they've got because the natural process of fermentation produces pure CO2. And so it's easy to get the CO2 and then pump it underground. But they have been pumping underground, and I think we're doing something like 500,000 tons a year for the past 3 years and storing it underground near the plant. And so that's something that's been important, is just to have a large scale plant in operation. And then there's a very large plant that's planned, a coal plant in the UK that is starting to, that has actually switched away from coal to burning biomass. And in the next couple of years, the plan is to start capturing the CO2 from that combustion. And that company, Drax, has plans to start a US plant as well. So that would be interesting to see. Yeah, I think this interesting question in the chat about small scale BECCS, and to me, small scale anything, like I've done a lot of work on solar, and one of the magical things that had solar grow was that it was available at any scale, from a tiny solar power plant on a calculator to a giant one in, say, the Egyptian desert, and everything in between. And so a lot of people say, well, couldn't we do something like that for carbon removal with small scale BECCS or small scale biochar, which is already happening, or small scale direct air capture? And there's companies trying to do that as well. And so there's potential there. The tricky thing, I think, is what you do with the CO2 after. And so what makes rooftop solar work really well is everybody already has an electricity connection to their house, and not everybody has a CO2 pipeline going away from their house. And so there's a little challenge, or possibly a big challenge, of doing distributed small scale BECCS or biochar or direct air capture, because somehow we have to collect that CO2. And so there are some efforts to do it. And I talked to one entrepreneur who became a billionaire doing grocery delivery. I think it was called Instacart. And he had this idea that I said, that's the problem. He said, well, we know how to deal with that problem. We know how to get groceries to millions of people's houses. And so we could do the same with taking the CO2 away from their house. So maybe there's innovative ways to do it at small scale. But that's a challenge, that how you get the CO2 and take it to somewhere where you can store it durably is a challenge.
Well, thanks, Greg. I appreciate that you provided for us this morning. We're going to move on now, if that's okay.
Thank you. Yeah.
There are no other questions. So there is just to point out, fun article about how Nuglaris Brewing captures their CO2, if anyone's interested in how beer and CO2 work together there. So just point that out for a little fun moment. But we're going to move on. And next, we're going to talk about carbon management activities in Wisconsin agriculture. And Diane Mayerfeld is going to be our speaker now. And she is the Sustainable Agriculture Coordinator for the University of Wisconsin-Madison Division of Extension. She helps educators and farmers learn about sustainable agriculture techniques and resources, including grants from the USDA Sustainable Agriculture Research and Education Program, which is SAR, or SARE if you're interested in the initials there. Never mind. Current areas of focus include climate change, working with diverse farmers, and perennial crop systems. She has a PhD from the Nelson Institute for Environmental Studies at the University of Wisconsin-Madison and researches silvopasture in Wisconsin. So Diane, I'm going to turn it over to you.
Thank you, Mary. Give me a moment while I try to pull up my PowerPoint. And is everyone seeing it all right? Anyway, this is, it's really exciting to present today, and it was a great introduction that Greg offered. So I am going to bring us to a more narrow focus on Wisconsin and Wisconsin agriculture, and where we are right now in terms of the bioeconomy. And just before I launch into that, I just want to say we're interested in this because of this interconnection between climate change within agriculture, its impacts on agriculture, but also obviously its impacts more broadly, the adaptations agriculture has to make, but then also agriculture has impacts on climate change, and all of these things are interconnected. So climate change has a wide number of impacts on Wisconsin agriculture. One of the really most impactful ones has been the change in precipitation patterns. We have seen a lot more precipitation in spring and fall, and a lot more very intense precipitation events. And these have primarily negative impacts on agriculture, which I've indicated in red. Sometimes it's positive to not have moisture stress right after planting, but delays in planting, soil compaction and other soil damage related to trying to do agriculture when the soil is too wet, increased erosion, delays in harvest, and decline in quality of the harvest as a result, disease pressure, and increased risk of flooding. And how we manage carbon in our agricultural systems can help us deal with some of these impacts. Greg made the point very well, and I think I want to try to make it graphically here, that we can't just look at removing carbon through the processes I'm going to spend most of my time talking about. Just Wisconsin agriculture emits about 20 million metric tons of greenhouse gases every year. So these are that's just in Wisconsin. So these are the figures based on US EPA's estimates, and they work together with USDA. for Wisconsin agriculture. And I really want to draw your attention to the bottom stripe here, the purple stripe, which is the greenhouse gas emissions from manure management. Those have been growing the fastest. The big red stripe on the top is nitrous oxide emissions resulting from application of manure and nitrogen fertilizer to our crop soils. The big one in the middle is enteric emissions, and that's just cows give off methane. But that has stayed fairly steady. In fact, it's gone down by about 1%. But we see this big increase in manure management emissions. And I'll circle back to that later. Why are my slides not advancing? Apologies. I'm going to stop sharing I'm just going to turn off my video in hopes that that will help a little bit. All right. There we go. But mainly what we are focusing on today is the carbon that we can pull out of the air by our management of our agricultural land and our forestry land. And here again are EPA's estimates of how much carbon we are either emitting or pulling out of the atmosphere and storing either in soils or in vegetation in Wisconsin. And I want to draw your attention to the colors that have check marks next to them. So the red line on top, we're not that interested in. So all of the stripes above that zero line are areas where our land use and our agricultural management are pulling carbon out of the soils and out of vegetation and emitting it to the atmosphere. And so what you can see is right now we have the lands that are remaining in croplands are actually emitting carbon dioxide to the atmosphere. I'll go into why that is in a bit. And we also have land that is converted to cropland. We continue to have land that's converted to cropland that is emitting carbon to the atmosphere. In Wisconsin, almost all of the land, almost all of the carbon removal is going on due to forestry. But there is a little bit that you can see at the bottom, that land that is converted to grassland, that little pink line at the bottom is removing carbon. So try to keep these numbers in mind. The key things is we want to flip that blue bar to being negative, and we want to do what we can to flip that purple bar to being negative, and we want to grow that the pink bar, so that it's bigger and it's removing more carbon. I'm gonna apologize. I want to see if I can go back, and because I think my thing flipped over. Yes. The slide advancing is just not working very well. I want to put this all into a little bit of context, which is Greg alluded to the Paris Agreement. And one of the things that happened at the Paris Agreement is that there was a specific focus on using natural carbon storage and the ability of plants to remove carbon dioxide from the atmosphere and store them in the soil as a key pathway to climate change. And specifically, they talked about pulling 4 parts per thousand, or increasing the amount of carbon stored in the soil by 0.4% annually, and that could get us a long way towards our targets. Unfortunately, that turns out to be very difficult to do, and I'll go into that a little bit. All right. So recall that I said, I showed those emissions targets, and all of our carbon capture, and basically including the forestry, is slightly less than the agricultural emissions right now for Wisconsin. So I'm going to focus primarily on the potential of increasing carbon storage, because that's really where, I think the focus of today's talk is. But I do want to reemphasize, and Greg made this point very well too, reducing our emissions is absolutely key to meeting our climate strategies. And some of the key things we need to do to reduce emissions are we need to manage our manure better. And this is actually potentially part of the circular bioeconomy. Recall that purple line in how our emissions are growing was the fastest growing part of agricultural emissions for Wisconsin. There is actually a technology that can help address that. So the reason that purple line was growing much faster than the other lines is because we are seeing increasing concentration over time in our dairy farms. And as we have these bigger dairy farms, they manage their manure differently. They manage their manure in liquid lagoons instead of doing daily hauling or dry manure management. And those liquid lagoons emit a huge amount of methane. And methane is a very potent greenhouse gas. It contains carbon, but per unit, the warming potential of methane is somewhere between 25 and 30 times greater than the warming potential of carbon dioxide. There's a technology where we can capture this manure and turn it into natural gas. And methane is natural gas. We capture the methane emitted by the manure. And then we can use it to generate electricity, or we can use it to heat, or we can even use it as a fuel for vehicles. But this is fairly expensive. And so even though Wisconsin has more than 300 farms that are very large, that are have more than 700 dairy cows or more than 1,000 animal units, we only have 39 of these manure digesters, plus 6 that are either planned or maybe in construction, under construction. And this is because of the policy environment in the US. Compare this to Europe, or compare this to Germany, which is a, relatively small country, bigger than Wisconsin, but much smaller than the US. And it has more than 10 times as many manure digesters as the entire United States. I will focus primarily on the right side. How can we take our agriculture and flip that line where currently our management of cropland soils is releasing net carbon into the atmosphere, and change it to one where we're actually storing net carbon in our soils? And there are 4 principles of soil health that farmers are already doing. Not all farmers, but they are an increasing amount of interest. So this is an area of a lot of potential. So I'll go into these soil health principles in a little more detail, but I also want to say adding trees to our landscape and converting, where we can, our annual cropland to pasture or natural habitat also offers huge potential for storing carbon. And one of the great things about this is a lot of these, or when done right, all of these strategies listed on this page have benefits in terms of water quality and in terms of biodiversity and other environmental benefits. So those 5 soil health principles, the first is to limit disturbance to the soil. Reduce tillage. Many Wisconsin farmers do this, but there's many who don't yet. And so there's a lot of room to increase our performance here. Fertilizers and pesticides provide chemical disturbance. And so reducing the use of those is also critical. And as we mentioned, nitrogen fertilizer has a whole other set of impacts in addition to its soil health disturbance that causes huge greenhouse gas emissions. And the thing that will limit disturbance the most is if we can transition to perennial crops. So I have a picture of hazelnuts on the right, and there's a lot of interest. This is still a very tiny niche crop. A huge amount of work needs to be done to, develop our ability to grow it and market it. But perennial crops means we get rid of the need for annual disturbance altogether. Keeping the soil covered also helps to keep carbon in the soil. And so again, all of these strategies are ones that Wisconsin farmers are already doing to a certain extent, but that we could do much more. Retain as much crop residue as we can, provide mulch, grow cover crops, and again, most of all, perennial crops do the best job of keeping the soil covered year-round. Keeping living roots in the soil year-round. Cover crops do that to a certain extent. We can integrate into our annual crops, we can integrate areas that have living roots in the soil year-round. So windbreaks, filter strips, grassed waterways. A relatively new concept of, instead of having a grassed waterway that just has maybe one species of cool season grass with fairly short roots, we try to restore native prairie in strips in critical areas in our cropland. Then there are perennial crops that people are starting to look at. And the one in the photo here is kernza, which is a perennial grain that the grain is much like wheat in terms of its food ability. Unfortunately, its yields are much lower than wheat, but you can see its root systems are amazing. Although this particular root in the picture is a particularly nice one, and you don't always get roots that beautiful. And again, perennial agricultural systems like perennial pasture and agroforestry do the best job of keeping living roots in the soil year-round. Adding diversity also helps us retain carbon. And we can add diversity over time by crop rotation. We can add diversity in space by things like strip cropping. We can add diversity by having, for instance, in our cover crops, not just planting one species, but planting multiple species. Again, in things like where we are putting perennial little strips of perennial crops in strategic areas in our croplands, we can add diversity in those perennial strips. Diverse pastures, and that's the photo on the right, obviously add a lot of diversity compared to a crop like corn or soybeans. And then we can add structural diversity by adding trees. And again, Wisconsin farmers are experimenting with all of these things, but it's a few farmers, and we could definitely increase the degree to which farmers are doing this.
Diane?
Yeah, am I at time already?
Yeah, this is all extremely interesting. And maybe people can talk more with you in one of the chat rooms, either at lunchtime or afterwards. If we could wrap it up, that would be great. So you stay on schedule. Thank you.
I will I do want to cover this really quickly,
Yes,
which is
perfect.
that there are some very serious challenges to sequestering carbon. And which is why there is this gap between what we want to do and what we have accomplished so far. The results vary. How much carbon you can store vary depending on soil climate and really critical management details. Storing carbon in the soil takes a lot of time. Losing carbon happens fast. If you plow your field once, you lose a lot of carbon. It takes many years of no-till to gain that carbon back. A warming climate makes this all harder because especially warm nights means that our soils want to lose carbon faster. And we have to be very careful that the things we do aren't causing more greenhouse gas emissions. And I think that's where some of those questions about some of the carbon storage and capture that Greg mentioned might come from in people's minds. So apologies for running over, and I look forward to talking more in the chat rooms, and I'll monitor the chat for questions and try to address them there.
Yes, that would be great, because there were a couple of things already in the chat while you were talking. So that would be awesome if you could just address those there and maybe hang around at lunch in one of those breakout rooms. I'm sure people would be happy to check in with you then.
Yeah.
Thank you again. Very interesting stuff. We're going to move on to carbon management activities in Wisconsin forestry now. So the project director, Bryan Van Stippen of the United Nation of Wisconsin, joined the National Indian Carbon Coalition, excuse me, the NICC, from the Ho-Chunk Nation, where he served as a tribal attorney for the Department of Justice before transitioning to the legislative office. As a legislative attorney, he was responsible for land acquisition and other land issues, including fee to trust, leasing, right-of-ways, and easements. Bryan, I'm going to turn it over to you.
Looks like we can't hear you, Bryan.
Maybe you're muted.
You don't have me at all?
Now we can hear you.
All right, that's much
Thank you.
better. I don't know what happened there, but technical difficulties as everybody's been having. So appreciate the opportunity from the Wisconsin Energy Institute to invite the National Indian Carbon Coalition to this presentation today. As Mary mentioned, we'll be working or discussing forest-based projects that are going on in the Midwest, and we've been working on with tribal nations within the state of Wisconsin. I just wanted to follow up on that last presentation.
Bryan, you're kind of coming in and out. So maybe be closer to your microphone and try not to move. It's just sort of fading in and out.
Yeah, I apologize. I don't know what's going on with my audio right now. I could come back after the break and switch over to phone audio if that makes more sense, since we're a little bit behind right now.
Now you're sounding good.
Now I'm sounding good. All right. I apologize again. I don't know what's going on with audio right now. Zoom just wants to give me headaches. But again, I appreciate the opportunity to present on the work that the National Indian Carbon Coalition and three tribal nations in the Midwest, stuff in the state of Wisconsin. Currently, we have a handful of projects here in the Midwest region, specifically with the Fond du Lac, Band of Lake Superior Chippewa Indians, as well as the Keweenaw Bay Indian community. Fond du Lac is over in Minnesota. Keweenaw Bay is up in the Upper Peninsula of Michigan. And what we have going on right now, I'll just get into a little bit of information as to who we are and what we're doing at the National Indian Carbon Coalition. So NIC was created by the Indian Land Tenure Foundation, as well as the Intertribal Agricultural Council. So ILTF and IAC came together in approximately 2011 to create the National Indian Carbon Coalition as a tribally owned and operated not-for-profit organization. ILTF and IAC have been working in Indian country for a combined 50 years, providing services to tribal nations, Alaska Native villages and corporations, Native Hawaiian organizations, as well as First Nations in Canada. So our role at the National Indian Carbon Coalition is to help Indigenous peoples explore the opportunity to develop carbon sequestration projects, not only on forested lands, but on agricultural lands as well. Just briefly, we received a USDA Conservation Innovation Grant last July to look at what Diane was just talking about with cover crops, row crops, looking at trying to get no-till practices instilled into tribal agricultural lands and enter those lands into a carbon market system with one of our partners called Indigo Ag. So Indigo has a marketplace and a process to get row crop lands, grazing lands, pasture lands enrolled into carbon projects, in which we believe not only can tribal nations take advantage, but any individual producer can participate in that marketplace. And you can go as low as 5 acres of land, as long as you're utilizing those practices on that land base. But again, we've so far developed these forest-based projects because we believe that the protection and preservation of these tribal natural resources are important rather than extraction or exploitation of those natural resources. And we can still be able to derive a revenue stream by putting them into a carbon sequestration project. But why do we do this? Because historically, tribes have been pressured to extract. I mean, it's just the nature of the beast. We see throughout Minnesota, Michigan, Wisconsin, line 3 with Enbridge coming through. There's a lot of controversy over the movement of fossil fuel sources across tribal lands, the extraction of those resources. And then those organizations that are doing that type of work notoriously take the majority of the revenue, or tribes receive minimal revenues from allowing those transportation of natural resources and fossil fuels across their lands. And it just has not been a good relationship for tribes over the last 100 years or so on protecting their natural resource base. So we want to ensure that we are keeping that natural resources in the ground, so that we believe that they're going to benefit the local community, specifically the tribal communities. So some of the benefits that we see, along with revenue generation, is preservation of tribal land ownership, and to return tribal lands back into the tribal hands. How do we get the reservation lands that have designated for the tribes under 100% ownership? Currently, that is one of the main issues that we are trying to engage with in Indian country, seeing tribal land bases. I'm a member of the Oneida Nation. We have 65,000 acre reservation, and the tribe only owns a minor portion of that land base on the reservation lands themselves. Promotion of land stewardship, reduction of greenhouse gases is obviously a major issue. And then the promotion of soil health, ecological diversity, water and air quality. So we call those co-benefits that we can track, engage. We're also looking into social and cultural factors as well. How does the benefit of these carbon projects provide societal and cultural benefits? Again, being able to use traditional resources, traditional medicines that were on the land base prior to climate change and extraction of those resources. Our primary activities at the National Indian Carbon Coalition, we work with these indigenous communities, develop a feasibility study on any natural resource base. And our focus has been on forested lands. Over the last 5 years, we're starting to expand into those agricultural land bases, as well as to grassland type projects. So trying to determine whatever sort of natural resource base a tribal nation would have, and seeing if we are able to make an economically viable carbon project out of that land base. We want to be an unbiased and independent resource for data. So we receive federal funding and philanthropic dollars to do this type of work. There is no financial request from the tribe to enter into a feasibility study because we want to ensure that those communities have that information so they can make informed decisions. And then one of the big things that we tried to do is do web map and GIS work, just map lands, map croplands, map forested lands, because that information is necessary and needed by the landowners. And sometimes we found that that information is lacking. So it's a part of the program that we've developed to help create that data, create that information, just so tribal leadership can see who the local landowners are, if they're tribal members, if they're non-tribal members, all that interesting data that is needed to make, again, these informed decisions. So quickly going through the project steps, I mentioned the feasibility study. Once we receive data and enter into a relationship with the tribal nation, it takes approximately 3 months to create the feasibility study. Again, that just shows whether or not a project might be economically viable. We then have to do the actual development of the project and creating the upfront data necessary. So we have to do a boots on the ground inventory. There's a third party quantification and verification of all of the data that is collected. So there's another party that comes in to ensure that the forest inventory data that we collect is accurate and up to date. And then once we get to that point, we send everything to the registry for their verification and review. So currently we're utilizing the American Carbon Registry's Improved Forest Management Protocol. And that process takes approximately 6 to 9 months. During that entire phase, we're looking at credit sales, trying to work what we call social responsible organizations, such as Amazon, Meta, Disney, Microsoft. We've currently sold credits to Airbnb, Dick's Sporting Goods, Mass Mutual, entities that have same or similar values to tribal nations on their environmental prerogatives. And then dependent upon the project type, we have monitoring, reporting, and verification throughout the duration of the project. Currently, we are developing projects on the voluntary carbon market space, and those projects have a duration of 40 years. But if you do develop projects on the California cap and trade marketplace, then that would be up to a 100-year duration. So the National Indian Carbon Coalition is working with the Nature Conservancy to roll out this program, and which we just call the Tribal Land Conservation Initiative, focusing on that voluntary market space to develop these projects. We have engaged with some tribes in Wisconsin. We know there's also some commercial logging operators that are developing projects in northern Wisconsin and in the UP. We're seeing more of this type of work being done. The state of Michigan Department of Natural Resources recently developed the first carbon project done by a state in the Midwest region. And we're seeing a lot of discussion in Minnesota, up especially in some of the ceded territory of the tribes, working with the state, working with the counties to see how there might be able to be a project in which all of the partners that manage that land base can develop a carbon project. So we see a lot of strong interest. Again, the commercial logging operations are starting to enter into these types of carbon projects. We believe that tribes have an opportunity to participate as well with their land bases, having a lot of conversations, not only in the Midwest, but in the Northwest with tribes in Washington, Montana, Oregon, Idaho, because again, there's a lot of forested lands in that region as well. So just all kinds of movement in this space as this marketplace continues to grow. Some of the things that we, again, with this Tribal Land Conservation Initiative is that the National Indian Carbon Coalition engages with the tribe for the entire duration of the project. So we are there for the entire 40 years of the project. We utilize philanthropic dollars to help cover some of the upfront third-party expenses for that tribal nation landowner to remove some of the risk. We contract with all of the third parties so that we can remove that responsibility and burden from the tribe itself. The size a little bit old, credits will not be sold for less than $10 a credit. Right now, we are selling carbon credits at $15 to $25 a credit, so that is a little bit outdated. But we will only work in which tribes approve the buyer of the carbon credits. That's one of the things that tribes had asked for. As we have engaged with their leadership, staff, and membership to make sure that we are not allowing polluters to continue to pollute, but engaging with organizations that are truly trying to offset their carbon footprint. We don't want to allow these organizations to do any sort of greenwashing, utilizing tribal names to just say that they're offsetting their carbon footprint, in reality, not doing as much work as that they could be. So that's a very brief outline of the work that the National Indian Carbon Coalition is doing in the Midwest. Again, trying to engage with more tribal nations. There's 33 tribes within the Midwest region, which includes Michigan, Minnesota, Wisconsin, and Iowa. We're starting to roll out our first handful of projects in Minnesota and Michigan, and getting some tribes enrolled here in the state of Wisconsin. So we're excited on our end. We think the next few years is going to be pretty hectic to get projects moving forward with tribal nations, looking forward to the opportunities to engage with any organizations that may have interest on this call today. Feel free to reach out. I'll jump to the contact information on the last slide here. And give me a call, shoot me an email. We had a lot of different discussions from organizations by doing presentations to entities similar to the Wisconsin Energy Institute, just seeing what other people are working on. We're always interested how we might be able to collaborate, and support projects that are going on in Indian country throughout the Midwest. So appreciate your guys' time today. I know that was fast and furious. Hopefully you could hear me well enough, but I appreciate your time today.
Thanks, Brian. Appreciate that presentation. And again, we're going to hold questions for the Zoom room either at lunch or after, just to kind of keep us on track so we can finish up the day on time. So appreciate your presentation. And we are going to take a short break now.